So in our last unit, we had learned about how you convert grams to moles. And then just in our last video, we learned about stoichiometry, where you convert the moles of one thing to the moles of something else. So what we're going to do now is we're going to combine those two together. And the reason that that's an important step is because when you're doing a chemistry experiment, when you measure the amount of something, when you put something on a balance, you don't measure the number of moles of something, you measure the mass of something. So when you're going to go get some sulfur dioxide or something like that, or some some magnesium chloride, or anything, when you measure it, you're going to measure it by the grams of the substance, not the moles of the substance. So one of the things that we have to be able to do is we have to be able to convert those grams to moles using the molar mass of the substance, and then do the stoichiometry step, converting the moles of one thing to the moles of something else. So the first thing we have to have is we have to have a balanced equation, and then we're going to convert those grams to moles, and then we're going to do like we just learned in our previous video, we're going to use the balanced equation to convert from moles of one thing to moles of something else. And then we can even convert those moles of the new substance back to grams. Okay, let me show you what this looks like. So example 4 says lithium metal reacts with water to produce hydrogen gas and lithium hydroxide. 6.28 grams of lithium metal is placed in a large amount of water. So here's our lithium metal. So we have 6.28 grams of that. And they want to know how many grams of hydrogen gas will be produced. So they want to know how many grams of this. So the equation's already balanced for us. So the first thing that I do here is we take our grams of lithium, I go to the periodic table, I look at the molar mass of lithium, and I convert my grams of lithium to moles of lithium. Okay, and again, that's what we learned in Unit 4 when we learned about converting between grams and moles and particles and all that stuff. Okay, so now we have moles of lithium. Now we just do what we learned yesterday. Now we go to the balanced equation. We take our moles of lithium, and then we put moles of lithium on the bottom. And since they're asking us about hydrogen, we put moles of hydrogen on the top. Remember that, how do you know which one goes on the top and on the bottom? All depends on this. If this is moles of lithium have to go on the bottom. And then whatever substance they're asking you about, that's the one that goes on top. Now, why is there a 2 there? Because 2 moles of lithium will make just 1 mole of hydrogen. Okay, and that gets us to moles of hydrogen. And then our last step is once you have moles of hydrogen, we use the molar mass of hydrogen to convert our moles back to grams. Now, notice I did this in 3 different steps. 1, 2, 3. You don't need to do that. The easier way to do this is just do it all in one step, just like this right here. So let me kind of go over this with you. So I took my grams of lithium right here. I used the molar mass of lithium to convert grams of lithium to moles of lithium, canceling out grams. I then, remember, here is my stoichiometry step right here, where I have moles of lithium on the top, and so I put moles of lithium on the bottom, and moles cancel, and I put moles of hydrogen on top, because again, that's what they're asking us about, was hydrogen, and the 2 and the 1 came from the balanced equation. So now I have moles of hydrogen, and then I'm going to cancel moles of hydrogen, and there are 2 grams in 1 mole of hydrogen. Notice that any time, this is a really common mistake I see, anytime you use the molar mass, this step right here or this step right here, it's always 1 mole. Don't ever use the balanced equation when you're using the molar mass. The only time you use the balanced equation is right here. When you're doing the stoichiometry step, that's when you use the coefficients from the balanced equation. Okay? Other than that, anytime you're using the molar mass here or here, it's always the number of grams in 1 mole. Okay, let me show you a couple more examples. So example 5, nitrogen monoxide, NO, reacts with oxygen gas to form nitrogen dioxide gas. How many grams of nitrogen dioxide are formed when 5.23 grams of oxygen gas is allowed to completely react with the nitrogen monoxides? Okay, so number 1, we have to write a balanced equation. So NO reacts with oxygen gas O2 to to form nitrogen dioxide gas, NO2. So we need to balance it, so we're going to need a 2 here and a 2 here. Now we have 2 nitrogen atoms on both sides and 4 oxygen atoms on both sides. Okay? And now we're going to start with the number that they give us. So we're going to start with 5.23 grams of oxygen gas, O2. And then our first step always is to convert those grams to moles. So I go to the periodic table, I look at the mass of oxygen, I see that there's 2 of them. So I put 32 grams in 1 mole of O2. And I know you guys hate writing units. Can't I just write 1 up there? Why do I have to write 1 mole of O2? Because it helps you figure out the next step. Because the next step now is, well, what do I do now? Remember, whatever's up here has to come down here. So that's why it's really, really important to use your units when you're doing this. So now I'm going to put moles of O2 on the bottom. I'm not worried about the number yet. I will just here in just a second. But now what goes on the top is whatever they're asking us about. They're asking us about nitrogen dioxide. Okay? And they want grams of nitrogen dioxide. But remember, the stoichiometry step, all you can do is convert from moles of one thing to moles of something else. So we're going to convert that to moles of nitrogen dioxide. Now I'm going to go to the balanced equation. The balanced equation tells me that 1 mole of oxygen will produce 2 moles of NO2. So 1 mole of oxygen will make 2 moles of NO2. And now my last step is, again, remember, whatever's here has to come down here. And here's where it's really easy to write a 2 down here. Don't do it, like I just told you. Anytime you're using the molar mass, don't put, it's always it's always 1 mole of NO2. Remember, the numbers don't move, the units move. So the moles of NO2 come down here, and then again I go to the periodic table. There's 46 grams in 1 mole of NO2. If I put a 2 here, if I mess up and I put a 2 here, 2 moles of NO2, that's fine. But guess what I have to do up here with my 46? I have to double that. Okay, the molar mass is the number of grams in 1 mole. So if you put 2 moles, that's fine, but then you're just going to have to double your number. A lot more work. That's, again, completely unnecessary. So in 1 mole of NO2, there are 46 grams. So now I just go to my calculator, and I start from left to right. Things that are on the bottom, I divide. Things that are on the top, I multiply. So 5.23 divided by 32 times 2 times 46. Equals, and I've got 3 digits here, so I'm going to put 3 in my answer, 15.0 grams of NO2. Okay, for this last example, I would recommend that you go ahead and pause the video. Go ahead and give this one a try, see how much of it you can do, and then unpause the video and come back and watch it and see how well you did. Okay, great way to figure out how much of this do I understand, how much can you do by yourself. So the first thing I'm going to do is I'm going to write a balanced equation. Hydrazine N2H4 completely reacts with dinitrogen tetroxide N2O4, producing nitrogen gas N2 and water H2O. Okay, so the first thing I need to do is I need to balance this equation. So again, it doesn't really matter where we start. Let's start with oxygens. I've got 4 oxygens here on the left. Here I only have 1, so I'm going to put a 4 there. That makes 8 hydrogens. So I need a 2 there to make 8 hydrogens. And now that means I have 4 plus another 2. That's 6 nitrogens. So I need a 3 right there. Okay, and now that equation is balanced. That's not a super easy one to balance, but it's not too bad, hopefully. Okay, and now you're starting with 200 grams of this N2H4. So 200 grams of N2H4. What's the first thing we always do if they give us grams is convert those grams to moles. Okay, and so the molar mass of N2H4 is 32 grams. in 1 mole of N2H4. And now I do the stoichiometry step. I'm going to go from moles of N2H4 to, what are they asking me about here in the problem? How many grams of nitrogen gas are produced? So I'm going to go to moles of nitrogen. Okay, and now I need the balanced equation to help me out here. Moles of N2H4, 2 moles of N2H4 are going to make 3 moles of nitrogen gas. So 2 moles of N2H4, 3 moles of nitrogen gas. Okay, and now my last step is I'm going to go, now I'm going to use the molar mass again, so it's always 1 mole of N2, and nitrogen has a mass of 14, but there's 2 N's, so that's 28 grams. And again, if I've done this correctly, everything's going to cancel except for my grams of nitrogen. So now I take 200, I divide by 32, I multiply by 3, I divide by 2, and then I multiply by 28. Okay, and this has 3 digits, so my final answer is also going to have 3 digits, 263 grams of N2. Okay, now, so here's just a quick, easy way to kind of remember this. And you might want to write this down. Grams. And actually, you know what? Let me change that a little bit. Grams of unknown substance X, let's say, just so we don't have to use an actual chemical. Grams of X to moles of X. How do you do that? You use the molar mass of X. Okay, that's what we did right here. And then you go from the moles of X to the moles of, let's say, Y, some other unknown compound. And how do you do that? You do stoichiometry. Okay, and how do you do stoichiometry? You use the balanced equation. Okay, and then you can go from the moles of Y back to the grams of Y using the molar mass of Y. So this is what we did right here. Using the molar mass of Y, that's what we did right there. Okay? So that's kind of just a kind of a little, almost like a map you can follow. Start with the grams of one thing, go to the moles, use the moles and the balanced equation to go to the moles of something else, and then go from the moles of that something else back to the grams of that new substance.